Good morning, students. Today we'll discuss in numerical methods. The another formula is Newton's forward interpolation formula. Newton's forward interpolation formula. Given the values of x, x0, x1, x2, x3, etc., y is equal to y0, y1, y2, y3, etc. Some data are given. We can find value in between x0 and x1. Given x value is given in between x0 and x1. Then we have to find out the corresponding y value. Or the x value, x1 and x2. There's a one value given in between x1 and x2. We can find the value of corresponding y value. For that, we use Newton's forward interpolation formula. The formula says that Pnx is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial delta square y0 plus u into u minus 1 u minus 2 by 3 factorial delta cubed y0 plus etc. This is the formula, Newton's forward interpolation formula. Here u is equal to x minus x0 by h, where h is the common difference. Here the difference between x0, x1, x2, x3 will be same. That is known as h. By using h, we can calculate u equal to x minus x0 by h. This delta y0, delta square y0, delta cubed y0, we can find it from the table. First, you have to make a table. From the table, we can find the value of delta y0, delta square y0, delta cubed y0. Substituting this value u and delta y0, delta square y0, etc. in the Newton's forward interpolation formula, we can find the corresponding y value. We can take one problem based on this. The problem says that the following table gives the values of the function f of x is equal to e raised to 0.1x at certain values of x. Compute the approximate values of f of 0.25 using Newton's forward interpolation formula. By using Newton's forward interpolation formula, we can calculate when x is equal to 0.25 the corresponding y value. For that, first we make the table. First we write the values of x and y in column wise. The values of x is equal to 0, 0.5, 1, 1.5, 2. The difference between each 0 and 0.5 difference is 0.5, 0.5 and 1 difference is 0.5, 1 and 1.5 difference is 0.5. Therefore, h can be taken as 0.5. Then write the corresponding y value. The corresponding y value is equal to 1.00. Then next value 1.0513. Next value 1.1052. Next value 1.1618. Next value 1.2214. Write the corresponding y value. Then make column delta y. First you have to make the first column delta y. To make the column delta y, we take the difference 1.0513 minus 1.00. The difference between 1.0513 minus 1.00 is equal to 0.0513. Similarly, take the difference 1.1052 minus 1.0513. The difference is 0.0539. Then take the difference 1.1618 minus 1.1052. The difference is 0.0566. Then next difference 1.2214 minus 1.1618. The difference is 0.0596. Then first we make a column delta y. For that we take the difference 1.0513 minus 1.00. The answer is 0.0513. Then next value 1.1052 minus 1.0513. 0.0539. 1.1618 minus 1.052, 0.0566. 1.2214 minus 1.1618. The answer is 0.0596. Next we make next column. Next column is known as delta square y. Delta square. Delta square, we take the difference 0.0539 minus 0.0513. The answer is 0.0026. Similarly, 0.0566 minus 0.0539. The answer is 0.0027. Then take the difference 0.0596 minus 0.0566. The answer is 0.0030. Then third column, delta cubed y. Delta cubed y, take the difference 0.0027 minus 0.0026. The answer is 0.0001. Then take the difference 0.0003. The next column, delta raised to 4y. Take the difference, that is 0.002. Oh, in Newton's forward interpolation formula, first you have to make a table, forward difference table. This is the difference table. First you have to make the difference table. The last value will be delta raised to 4y is equal to 0.0002. Then we can calculate the value of when x is equal to 0.25, corresponding value f of 0.25. We have to calculate when x is equal to 0.25, what will be the value of f of 0.25. For that, we use the formula. In the formula, first you have to make the value of u. To find the value of u, u is equal to, the formula is x minus x naught by x. Here x is equal to, x is taken as 0.25. 0.25 minus, then x naught is equal to, here x naught is equal to, first value 0, by h is equal to 0.5. Therefore, 0.25 by 0.5, the answer will be 0.5. Therefore, the value of u is equal to 0.5. Then y naught is equal to y naught. From the table, we take these values. Take the upper diagonal values. This 1.00 taken as y naught. This is taken as delta y naught. This is taken as delta square y naught. This is taken as delta cubed y naught. This is taken as delta raised to 4. In this formula, substitute the value of y naught. 1 u is equal to 0.5. Delta y naught is equal to 0.0513. Delta square y naught is equal to 0.0026. Delta cubed y naught equal to 0.001. Delta raised to 4 is equal to 0.002. Substituting the formula. Then we write the formula. We can write the formula. This is the table. In the table, Pnx, that is Pn value is equal to 0.25. Pnx, that is equal to y naught. Y naught is equal to 1 plus u is equal to 0.5. Delta y naught is equal to 0.0513 plus u is equal to 0.5 into 0.5 minus 1. Delta square y naught is equal to 0.0026. Then 0.5 minus 1, 0.5 minus 2 divided by 3 factorial. Delta cubed y naught is equal to 0.001 plus 0.5 minus 1, 0.5 minus 2, 0.5 minus 3. 0.5 minus 3 divided by 4 factorial into 0.0002. When calculating this value by using the calculator, we can easily calculate the value. This value will be 1.0253. The value is equal to 1.0253. That means f of 0.25, when x is equal to 0.25, the value of y will be 1.0253. This is the required value. But by using Newton's forward interpolation formula, we can find the value of y when x is equal to 0.25. When x is equal to 0.25, the value of y is equal to 1.0253. First we remember this formula. The formula says that y naught plus u into delta y naught plus u into u minus 1 by 2 factorial delta square y naught plus etc. In this formula, to calculate u, we use the formula x minus x naught by h, where x is equal to 0.25 minus x naught is equal to first value 0. Our 0.25 minus 0 by h is the common difference, that is 0.5. Therefore, u is equal to 0.5. From the table, we make a table. From the table, we take the upper diagonal element. This is the upper diagonal element. This is y naught. This is delta y naught. This is delta square y naught. This is delta cubed y naught. This is delta raised to 4 y naught. Substituting all the values in the given formula and solving and calculating, we get the value of function is equal to 1.0253. That means when x is equal to 0.25, the corresponding value of y is equal to 1.0253. This is the procedure for calculating the value by using Newton's forward interpolation formula. Okay.